Well, I'd like to welcome everyone to our presentation today. We're so honored to have Matthew Slaughter, who's going to talk to us about soils. The title of his presentation is Soil Brought to Life. And just a little bit about Matthew to begin with. He's the founder and president and Laboratory Director of Earthfort. He focuses primarily on customer support through consultation and education, in addition to responsibilities in product research and development. As the creator of Earthfort's products, he's constantly striving to help customers understand products to the greatest advantage of the end users. As a scientist, philosopher, and poet, Matthew's always learning and attempting to integrate natural holistic processes into agriculture. Growing up, he was deeply connected with nature, observing from bullfrog development from egg to tadpole to full-grown frogs at the age of 9, to spending countless hours and days hiking, camping, canoeing with family and the Boy Scouts. And whenever he's not working at Earthfort, he can be found walking in the woods of Oregon with Kong, a 70-pound Black Chow, or creating music or artwork with his wife of over 25 years, Melissa. We want to welcome you. I also want to welcome Kinzer Neiden, his assistant, who will probably have some things to say as well. And we welcome you both.
Great. Thank you. All right. So, wonderful. I'll probably talk a little bit more about myself as well, but let me start. I'm going to share my screen. So first of all, while I'm getting that all set up, thank you very much for having me. It's always fun to get a chance to talk and share what we're up to, and especially to such an international group that's so involved in community development. So that's a really important part of the whole aspect. I heard somebody said while we were visiting that soil was the most important part of the agriculture, and I would counter that with the farmer is the most important part of agriculture, and that the soil is one of their tools. So, it's all about the farmer. So keep that in mind too. Even when we're looking at the soil, again, that's part of the holistic. The holistic approach is this idea that, it's about the whole system. You have the soil, you have the crops, you have the farmer, you have the consumers, you have the impact on the ecosystem, always taking into account the environment. Water is another big critical factor in agriculture that is directly related to the soil. So it's always, even though my specialty, I guess you could say, or my expertise is the soil. Let's see, this is not over there. Why is this not working? Here we go. Hopefully you see Earthfort, soil brought to life. I can't see it, so I assume
yes, it looks good now. Mm-hmm.
So so Earthfort is really about multiple tiers and multiple perspectives on how we approach, the ecosystem. It's part spiritual, certainly emotional. There's the science of it. There's, ecology as well as nutrition, everything. We just do so much work, and when I say I'm a scientist, I am not an academically trained scientist. I consider myself a phenomenologist or a Goethean scientist, where direct observation over time is the point, and we don't approach science from the perspective of trying to prove or disprove anything. We don't create thesis and hypothesis. We just let nature tell its own story, and then we work within that structure to help people adapt and work within that within that natural setting. So, and that'll make a little more sense as we go through some of my talk here. Let's see, what am I going to say now? So, right, who is Matt Slaughter? So thank you for the introduction. That was really good. So I don't have to say a whole lot about myself. I am an artist. I am a scientist. I founded Earthfort in 2005, coming out of a laboratory. So I started working with the Soil Laboratory in 2003. And one of the questions that came out of the laboratory, very academic, it came out of Oregon State University, research scientists originally founded the lab. And it was very focused on the analytics and the numbers, right? Here's the numbers, here's the soil profile, the data about your soil. But the problem was there was a disconnection. And that disconnect was, what do I do with this information? How do I use some perspective on the soil to make decisions that might help improve it, help improve my crops, and what are the things that are related to it? So I decided to form an offshoot of the lab, Earthfort, to address the question of how do we approach correcting these problems that we're finding in the testing? How do we help farmers adopt practices that improve the health and condition and function of that soil? So that's really what Earthfort was founded on, the premise of this practical application, if you will, of this knowledge of soil science. And I'll talk a little bit about the kind of testing that we do and everything. So I took over, and in 2010, basically the professor and my partner retired, and I took over completely her work, and now I've just been doing what I'm doing. I invent products, I invent practices, and help people adopt practices. So I'm sure you've heard of, there's, in the regenerative, sustainable agricultural world, there's some real key pieces that everybody kind of talks about frequently, which is adopting no-till practices, doing cover cropping, proper crop rotation, as well as animal management, are all really key aspects to like basic foundational components of a sustainable agricultural approach. However, what I've discovered over the years is that it's not always enough, and it's not always the right tool depending on the circumstances of the farmer. And one thing that I've learned is, and a lot of you are outside of the US, which is good because the US agricultural approaches are very appropriate for a portion of US agriculture, but they do not translate and adopt well into, let's say, rural Africa. A no-till system is not even a concept outside of huge over-tilling practices of the US and Canada too, no offense to the Canadians. The point being that they're all tools, they're practices. So we look at all of those things and to help people determine whether or not they actually need to adopt a no-till system or conservation tilling, or in some cases they need to till the heck out of the soil, And then there's also the balance of chemical use and how you use fertilizers and chemicals, herbicides, other types of pesticides to create a balanced system that's functional and in congruence or coherence with nature, right? So anyways, I do a lot of fun stuff like that. Let's see, next. Now, my history in the field, I said I've been around, and I have been from, let's see, the poorest country I worked in was Suriname until I went to Haiti and worked with Haitians. I've done work in South Sudan. We've people in Kenya. I've got projects in Uganda and Ghana. We're starting up some interesting projects, which I'll talk about. I've been to Ukraine, worked in Ukraine, up in Canada, all over the US. I have projects in Europe, Australia, New Zealand, all throughout. We're working with folks in Uruguay, Paraguay, Argentina, Brazil, the Mexico, throughout Central America. I've been to Nicaragua, Guatemala. I've done work in Haifa. So those of you who are familiar with the work in Haifa, I've helped, was it 2010? I went and consulted with the Garden Center in Haifa at the Baha'i World Center, helping with management of the terraces as well as the gardens in Baji. You know, and just have had a wonderful breadth of experience. I've done talks, I've worked with farmers directly on the ground, consulting, and we'll talk more about some of these things. But just the idea that, you know, I've been doing this for almost 19 years now, and I have a lot of fun doing it. COVID has put a real damper on all that. I haven't been able to travel in a year and a half, so that's been an awful blow to our work, because going and working directly with the people is the best and fastest way to transfer knowledge. So especially in the more rural parts of the world. But anyway, so that's just a little bit about me. And if, you know, as we're going through, you know, type in your questions in the chat or whatever, and we'll try and get questions answered by the end of the thing. So let's see, and I've already talked a little bit about what is Earthfort. So real specifically, Earthfort is a soil testing laboratory, which we focus on the living component of the microbiology of the soil. So we measure bacteria and fungi populations in the soil, both total populations as well as aerobic populations. We do protozoa enumeration, and we do nematode analysis, and we can determine not only to functional group, but also to genus of nematodes. So we can help folks, that one specifically is to help farmers not spray chemicals for nematodes. Most nematodes are beneficial. Most laboratories that do nematode testing only look for root feeding nematodes or parasitic nematodes, whereas we look at the whole, try and look at the whole population of those nematodes and say, look, your balance is okay. You don't need to spray a nematicide to deal with one root feeding nematode. That's not going to cause you damage. But if they have too many, then we can look at different integrated management practices. So
Matthew, real quick, could you, for folks who don't know what a nematode is, could you just say briefly what that is?
Okay. So nematodes are microscopic worms or roundworms. They are, most of them are less than 1 millimeter in length. You can see some of them with the naked eye, but most of it is, everything we do is direct microscopy. So you can, tiny, tiny little worms, and they're everywhere. They're one of the most ubiquitous form of life on Earth. Even down at the bottom of the ocean, in those volcanic trenches, they found nematodes, and in the atmosphere, floating in the dust, they found nematodes. And in the Arctic, that's one of the things that's waking up as the polar ice caps melt and the permafrost is melting. Nematodes are actually showing up that had not been known to be in existence for hundreds, if not thousands of years, that were thought to be extinct, and they're actually waking up. So they survived the permafrost, and now they're waking up. And so, yeah, they're everywhere. They're interesting. They're, yeah. So, and then also, most of you know bacteria and fungi. You know, when we think of fungi, you think of mushrooms, but all mushrooms are fungi. All mushrooms start off as microscopic fungi in the soil. Not all fungi produce mushrooms, but all mushrooms are fungi. Most people are familiar with mycorrhizal fungi as a symbiotic relationship with the roots of plants, but we look at the whole population. You know, there's a few hundred, maybe 1,000 species of mycorrhizal fungi, and they estimate 100 to 200,000 or 300,000 species of general fungi. So we look at the whole population and not just specific ones. Although we can facilitate, if you're interested in your root colonization of mycorrhizal fungi, we work with a lab that can do that as well. So anyways, and then and protozoa are Amoeba Flagellates, ciliates are the main groups of those, and they're larger predatory types of single cell organisms that are basically they eat bacteria, fungi, and each other, and are a major component in the biochemical processes of releasing nutrients into the soil. So we study those populations, or not study them, but we enumerate those populations so people know how well the nutrient cycle is working in a natural way. And that really helps guide ideas of fertility requirements, nutrient needs of the soil. So anyways, yeah, that's a good point. I was more interested in the people this time than the organisms. Somebody said, somebody asked me, well, what is it about the soil that you find fascinating? And I say how it helps people, and not the organisms themselves as being something of a terrible great interest. There's plenty of scientists studying the millions of species of these things. And I'm more interested in looking at getting a perspective on how they can help the farmers. So speaking of the farmers, so here's some of the folks that we work with. So blueberries in Oregon, quince. Those of you who are familiar with quince, we have a friend here in the area growing quince and selling it mostly to New York and LA. So, and if you're not familiar with quince, it's an apple-like fruit that is excellent for baking, and it's real popular in South American and also Persian cuisine. So anyways, but we work with corn growers in Illinois, soybeans, we got blueberries in Oregon, we work with dairy farmers. We also do horticulture, so we work with rose gardens, golf courses, landscapers, all kinds of different folks. And then this is in the lower right-hand corner, that's in Kenya. That's a special project. We sponsor an educator who goes in and helps them it's teaching Maasai women how to do agriculture in a very holistic way and without costing them a lot of money. We'll get into some of that. So one of our big projects, and this is the one that kind of started a lot of our international work, is working with Haiti. So of course, many of you are familiar with the plight of Haiti. Over the last 10, 12 years, they've been just pummeled. I don't know what other word to use, between hurricane and earthquake and political unrest. Just a real, they've just been battered, and their high population, really low income levels. So we go in, I'm working with a nonprofit organization out of Pittsburgh called Partners in Progress. And what they do is it's an agroecology project where we're going in and we're not teaching the farmers how to farm. We're teaching educators how to work with farmers on farming better, using better practices in Haiti. And so we're teaching the teachers in this case. It's not, it took me 5 years to get into this program because the facilitators only bring in experts when the farmers themselves ask for the knowledge. So I'd been familiar with the program and it had been helping from a distance for years. And then finally the farmers said, we want to learn more about the soil people. That's how they put it. So I went in and, basically all I did was I educated them on the living component of the soil. I talked to them about bacteria, fungi, protozoa, and nematodes, but then we also, different agricultural practices to help reduce erosion. So they did contour swaling as one of the components. We taught them how to make compost using their own natural products. And then also an idea of compost tea, how to liquefy the compost in a way that they could apply biology and food resource to the soil to help rebuild the life in the soil. So a very hands-on experience with these guys. Here's some of the tea. In rural rural Haiti, the infrastructure is pretty awful, I guess you could say. They have internet access through cell phones, but they don't have any way to recharge their cell phones because there's no electricity, there's no running water. So what we did was we built a this compost tea brewer, and I won't get into a lot of details on that, but if you're curious, we can go into more detail. But basically, it's an aeration system. You have to aerate and agitate the water. In order to do that, you have to run a pump. In order for the pump to run, you have to have power. So one of the fundraising projects was to bring in solar powered equipment. So the really rugged, I think the next picture has a little bit better shot of it, but you know, there's a battery, a big battery and a solar panel. You can charge it all day long and then you can use it. And they love that because then they can charge their phones and it just makes it a real easy. And it's, you know, it's not terribly expensive and it's small enough to keep secured. You know, there's theft is always a problem in these kind of places, but you know, and this was a, you know, obviously it's hot. I want to say that it's hot in Haiti. If you've ever been to Haiti, it's brutal. High humidity, high heat. It's lovely, especially for an Oregonian, where I don't mind the rain, but man, the humidity. Anyway, so here's the little solar panel. You can see it, the 4-panel folds up really nicely. You can go on a backpack. One of their major modes of transportation is motorcycle. So everything that they do has to be very portable, right? And so, and rugged. So this is, you know, this is only 45 miles outside of Port-au-Prince. And those of you who are familiar with living outside of the US, 45 miles translates to 6.5 to 8 hours of travel. So it's quite a ways out in the mountains. And this is on the side of Haiti. It's Delande. It's not the part of Haiti that was just recently hit, although we do have a project starting in that, in the lower, was it the southwest corner of Haiti. They've got projects started. So this project is just one of these projects where all the farmers are doing most of the talking. So this was my second trip. So all I was doing is observing, because the first trip I had trained everybody, and then the second trip was just observing and making sure that everything, that they weren't saying anything too crazy. But again, contour swaling, different projects. One of the things that we do, somebody mentioned they're planting trees. Part of the agroecology program in Haiti, of course, is replanting trees for multiple reasons. One, obviously for shade and for protection of the soil, permanent protection, but they're planting leguminous trees, and leguminous trees will fix nitrogen, and those leaves can be harvested and utilized in a composting operation. So they're actually growing their own materials for supporting their compost operation while generating shade and soil stability. So it's a really kind of a fun project. Now, these guys really wanted me to teach them how to do laboratory work. They even bought a little microscope and had it in the classroom. And it turns out that is just not a very feasible operation, because you need electricity to run a microscope, and the level of technique, it's very technical training to do that kind of work. So they really could never get a lab set up. However, I've started a new project, and this is the fun part for me. I'm trying to, this is new for us. We've just been working with it for the last 1.5 years, and I think it's probably going to be one of the most exciting advances in soil management in the recent history, that is going to make a huge difference for all of you who are working with people in agriculture, as well as the farmers and everything. So this is, you ready for it? Okay, here we go. This is one of the most important advancements in soil health practices in probably forever. Those of you who are familiar with like the Cornell, I see a Cornell shirt, so thank you, go, yeah, yay Cornell. Cornell does a soil health assessment. It's a very expensive and drawn out test that you have to send lab samples into the lab. Earthfort does some very, we do great testing, and but it's very expensive and it's hard to get the samples from Haiti to the US. Even the thought of the cost of shipping alone is prohibitive for most farmers in the area. So what this is a technology that was developed in the last few years by a scientist in New York that I've been collaborating with for a couple of years now on trying to develop this thing. And basically what it is it's a way to test the soil microbiology in the soil with a cell phone. And that's the only technology you need. You can just need to take a picture with your cell phone, and it will process and give you information about the health of that soil. Essentially, you take a small sample of the soil, you liquefy it, and you put a couple drops on these little cards, and then you take a picture of it, and it uses optical technology to determine the density of the bacteria and fungi in that sample. It's super cool. My lab has adopted this as our core testing because you can do it in the field in real time, or you can send it in the lab. We can do it that way too. And this kit that includes 10 tests is retail cost is $135. So it's very accessible, little portable kit. As long as you have a cell phone and it can at least get a connection every couple days to the internet, you can run this test. And the key to it all, and it tells us a lot about what is going on in that living soil and how to manage it. And that's where I come in, is where these guys have created this test, but they don't know what to tell people to do with it. And that's where my role comes in, because I have all the experience of helping people understand if you're growing cassava, the soil microbiology needs to be in a certain balance with a certain amount of carbon content in the soil in order to be functional. And if it's not there, then you can make compost, or you can find other resources that will help feed and get that soil where it needs to be healthy enough to support the plant that you're trying to grow. So that's where the ecology, we do a lot of, we use ecological succession. So each plant grows within its own set of spectrum of plant growth, from weeds to trees and everything in between. And of course, each environmental state has a different set of plants, but the functionality and the position of those plants within the ecological succession has a direct correlation to the microbial population in that soil. So by looking at the microbes, we can say this is going to work or it's not going to work very well, and what happens when you get the microbes working correctly, the natural nutrient cycle works correctly, and you don't need as much fertilizer or nutrients. And also disease pressure and weed pressure will go down naturally as you get that soil functioning correctly. And so now this is a very simplified, we've got a lot of reading resources and stuff available. That's a very simplified way to look at it. But when you're working with a farmer, that really is the way it has to be explained, is that simple explanation, and say, if you're trying to grow a lemon tree in a soil that's supporting, grass, you're going to have trouble. You're going to have trouble growing that tree. But if you work on and understand the soil processes and can build that soil up to the point where it can support the tree, then you'll be more successful. And that's basically what I've been doing for the last, I don't know how many years I've been doing this. Oh, I said almost 19, right? So a very simple kit. We don't go into the details. I think there's links. I don't know if there's a link. There should be a link. It's microbiometer.com, and you can go and check it out for yourself. They have some videos, explanations. You can buy this stuff right online. They have classroom kits as well. So a lot of universities and schools are adopting this for their soil classes and using it as training, because it's 100% dependent on the process and 0% dependent on technique, right? So the clarity of the information is really, really helpful. And when it comes to other relations to how the chemical cycle is working and how the physical properties of the soil, then those are things that you can add into this information. So basically what they've done is they've made soil biology accessible to anybody who cares. And for me, for my goals and the way Earthfort operates, that's just great. That's just, I've got, my microscopes cost $20,000. And to set up a lab to do what we do is well over 100,000 US dollars, and takes months of training just to be able to do it. And now I can train somebody there's a 5-minute video that will teach somebody how to get, a lot of the information that we've been able to produce over the years. So for me, it's very exciting, and it's very accessible, because it just really opens the door for a whole new way of looking at the soil and accessibility to the farmers. So, and I did mention, some further reading. I understand that there's that Life in the Soil is part of somebody, like part of this group is doing a book club or something like that on that book. Great book. Edible Forest Gardens, I helped edit that book. We helped edit the section, and there's a beautiful section in there about the whole ecological succession and the balance of biology and the different plant groups and different systems. So it's one of the better published perspectives on that information, very focused. And then soil microbiology, ecology, and biochemistry, that's for the hardcore science. That's my Bible. That's the one I go to all the time. And it's the detail in there is tremendous. And it's 2 whole chapters just on the nitrogen cycle. I think a third of the book is devoted to the carbon cycle. So it's and then it's all about the life and the, basically the biochemical processes occurring in the soil. Pretty deep stuff. A lot of universities use this as their textbook. So yeah, so at that, that's kind of all I wanted to say. I ran a little over, but hopefully you guys have some questions and have some lively conversation if you like, and I'd be happy to do that. And thank you again for having me.
Thank you, Matthew, for the presentation. We do have some questions. I wonder, Marvius in Uganda, if your connection's good, do you want to come on and ask your questions, or would you like me to ask them? They're more technical in nature, so let's see if you want to come on. The first one I'll ask just while Marvius is deciding is, oh, there you are. There you are. Go ahead.
All right. Thank you very much. Thank you, our presenter. I wanted to ask a question. Have you done some analysis on fungal hyphae and the relation with the regulation of nematode population for farmers to know how, for example, the hyphae of the fungi can help them reduce the nematode population? Also, I had another question about do you have a tool which can be used to analyze the population of the phages? Because we know there are those phages that produce or regulate on the populations of the bacteria naturally. And these ones can be used to prevent antimicrobial resistance in terms of use of chemicals to regulate on the population of microbes. I don't know if you've done something. I'll be interested to get something more about that.
Yeah, we don't do anything with phages. And the testing that we do, I've done my databases. I've been told my database is probably my greatest asset because I have over 30,000 soil samples that we've processed in the last 15, almost 20 years. That the diameter of the fungi is something that we're keenly aware of. And so that's something that we do actually measure when we do the direct microscopy work. Also, nematode populations, you know, the distribution of those populations. What we haven't found yet, and I haven't done the research either, because I'm not a research scientist, so this is something for a researcher to look into, but we have not done the research to say fungi population versus nematode population. We just know where they're at, and we look at the functional groups. We can tell the difference between fungal feeding nematodes and root feeding nematodes, but the you know, I haven't seen any kind of real direct correlation between those two sets of population. So, but that's not to say it doesn't exist. You know, our general approach from a practical perspective is to maximize diversity. This may sound familiar to some of you. Maximize the diversity and limit the things that would oppress the system. So if there's something that is causing one segment of the population to be diminished for some reason, let's say you spray a fungicide to control a disease on the plant, that fungicide is probably going to have unintended consequences on other aspects of the fungal population. So you want to remove those problems, but at the same time, you can't sacrifice crops. But maximizing diversity, because a lot of times those diseases are manifesting themselves because they're opportunists. And if you don't have the diversity present to create a healthy, well-balanced system, then you know they take advantage, right? It's so that's one of the approaches that we use. Those of you who might be plant pathologists that's not a popular statement, you know. So, but I like to make it anyways because I really believe it. There is no such thing as disease. So, you know, if you take that perspective, then it changes how you approach managing the agriculture. So, you know, now there are such things as opportunists and there are true pathogens, you know, but again, they're only manifesting when conditions allow it. So that's why it's important for us to look at the environment. Okay.
Matthew, would you say, there's a question here that prompts me to ask, would you say a little bit more about, I think what you alluded to is that in the field, people can often do like handheld chemical testing, right? And people can do, you know, kind of physical soil tests, right? Clump tests, ribbon tests, those types of things. And so I think what you're saying is now finally people can also do tests on the soil food web in the field. That's what you're saying, right?
A very call it a very simplistic and very specific set of, it's basically you're looking at total bacteria and total fungi in the field in real time. And that's the foundational, it's the cornerstone of the food web, basically. At least from my perspective, you know, I look at protozoa, nematodes, I look at aerobic components, but those are very difficult to do in the field. But that fungi, and being able to see the fungi and bacteria in that balance it's just, anyways, it's going to be good. We're just getting started too.
And so do you advocate that farmers do those chemical tests and physical tests in addition to this test, I'm assuming?
Part of understanding the system is knowing all of it as much as you can. The more you know about your soil texture, the more you know about, you know, if there's any real deficiencies in your soil, organic matter content, anything you can do to gain knowledge about it is going to be valuable. But I will say this, and you know, you can just observing so many soils and so many plants growing, if you're trying to grow grass will grow and it doesn't care about your soil texture. It doesn't care about your sand, silt, and clay content. Grass will grow where grass wants to grow. You can grow it in a heavy clay here in Oregon, in the valley. We got people growing grass in the southwest in sandy soils. if the environment will support it, grass will grow in those soils. And there's different species, different varieties of the grass. But the reality is that the physical properties of the soil themselves are probably the least important aspect of whether or not a plant will grow there. And then the chemistry is the second component, because you really need to make sure that there's nothing toxic. No, you don't want toxic levels, and you don't want very deficient components. Organic matter is the third most important thing, and then the life is, or I should say the second most important thing. Life itself is the most important thing. I like to remind people that chemistry happens on Mars, but there's no plants.
Well said. Well said. Great.
And so, that's just part of the, again, trying to be a simplistic, not simplistic, but just a real practical perspective on these things. We spend hours talking to research scientists. We can go down a rabbit hole, and we can spend weeks and months talking about a single bacteria and its metabolic processes, but that doesn't help a farmer make a better crop or feed his family or be able to go to market. So.
Great. And also, I know that Janet and Ned have their hand up. We'll get to you in just a second. There's one question I think fits really well with this, and that's from Bill Hazen, who's asking, do you find any correlation between soil microbiology and perennial weed pressure? Seems like that's a good follow-up to that.
Yes, there is a lot of correlation between soil microbiology and both annual and perennial weed pressure. Annual is a lot easier to work with than perennial, of course, because perennial weeds fall into that zone of plants where most of our crops live. Most of our crops are actually perennial grasses. Even though we don't grow them that way, that's kind of what they are. And so perennial weeds are a real challenge when it comes to managing the system. And then also, is it an invasive or a native? It also changes. So it's a lot of practices and a lot of work to manage the perennial weeds. So that's one of the biggest challenges for any farming situation is how to manage the perennial weeds. So yes, and there is a correlation, and it's deep and wide as far as like the microbial populations. And then one of the other areas of testing that is coming along, but is still I would say in its infancy, maybe adolescence, depending on who you ask, DNA sequencing and microbiome information about the full diversity and speciation spread within those systems. Right now, what's happening is just too much information, and nobody can make sense of it. So there are people, of course, working on that. Yeah. So anyway.
Great. And we have other questions. Let's go over to Janet and Ned and let them ask their question. And I'd love to hear from Kinzer too, if there's anything that we want to invite her in for in particular.
Yeah, of course. I mean, that's a really broad question, my viewpoint, but I really do value taking the holistic approach and being able to help people from every different realm, every different corner of the world. We all have soil and work with it in some way. And that's the real valuable part. It's the holistic approach is the way to look at it in my perspective. And there's always going to be problems with the soil. There's always going to be something that you'll want to create a solution for, like Bill, I think it was mentioned, thinking about weed pressure. And one of the greatest shifts as I started working with Earthfort is how I understand what a weed is, and the way that Matt talks about weeds is very different from how I was raised to talk about weeds. You spray them and you get rid of them. But if you think about it in the way that, an oak tree growing in the middle of a cornfield is a weed, it's a very different perspective. So I'm learning a lot through this work, and it's valuable to be able to help people from all different corners of the world with it.
Wonderful. Well, Janet and Ned are in Uganda. So let's see what questions they have, and then we'll go back to the questions we have in our lineup.
Okay, I'm Ned Cundall. I've just been in Uganda about 1 year. The soils here are very reddish. I think they're usually called lateritic, just as we knew in Cameroon and Tanzania, and I understand in Australia. Can you make any broad generalizations about life in the soil here as compared with, let's say, the brown earths or black earths with Bill Hazen in Ontario?
Yeah. What you're looking at is a sand, silt, and clay distribution, and some different types of mineral contribution to that soil that, you know, creates a tint. As far as I'm concerned, it's just a color. It's not anything else. It's just a color, and you can get the life in the soil is going to be there. Right now, there's life in all of those soils, even in the desert. You know, there's some deserts in South America. I always forget the name of the desert in South America. They're on the West Coast that, you know, basically they say there's no life in that desert. And they only say that because there hasn't been any recorded rain for several hundred years. Well, it rained. And what did it do? It exploded. It was amazing. You know, you can go online and see this dead place came to life. All you needed was water. Your soils in Uganda, and I'm really excited to know that you're there, because that is, we just finished up the USAID grant to go into Uganda to teach youth how to use this microbiome kit, and give them the technical skills and also a job, right? To give them a job that they can run around and do the testing for farmers, and then help them, give them some other knowledge. So your soils will be able to grow plants. You just need to understand life in it, where it's at, and how it relates to what you're trying to grow, and then start looking at the natural resources to help improve it. You know, I know a lot of the programs, well, I won't get into that because that's the social political side of it, and that's a whole nother talk. But, you know, your soils are alive, they have biology. It's just making sure it's in a good balance and finding ways to help make it a little better for those farmers. So
yeah, things can go really, really fast here. It's very amazing. Our prejudice, if you like, is that forest cover is even more important here than it would be in temperate countries. Thanks.
Yeah.
Well, and that's a question that I have that I think might be interesting for folks here. I'm been learning and teaching permaculture for many years. And so question I have is, when folks are transitioning from annual systems to perennial systems, what kind of, you know, insights and support can you help them have so that they're going to set themselves up for success best?
Yeah, the short answer is reduce the disturbance of the soil and increase the carbon content. Organic matter, life, get carbon up, increase the fungal content of the soil. Annuals prefer bacterially dominated systems with alkaline conditions. Perennial systems, kind of like a balance of fungi and bacteria, with more neutral to even slightly acidic, and so on and so forth. And so as you climb the scale of carbon content in the plant, so that's where the kind of the thread connects. The carbon content in the plant reflects the carbon content of the soil. And there's a fungal to bacteria component that, you know, the simpler isn't the right word, but annual plants prefer bacteria and perennial plants prefer fungi. And it has to do with all of these metabolic processes, structure of the soil, air and water movement, how carbon is made. So organic matter is only one component of the carbon in the soil. And there's a lot going on in there, and it affects the pH of the soil. It affects nutrient availability and how well those plants will function in that sense. So yeah, permaculture is is a wonderful practice. You know, and that's the other thing too that I want to be really clear on, is that all practices are good practices if you understand why you're doing them. If you're just doing something because you read it on the internet, then you lose. And I know this crowd, honestly, I know this crowd is not falling prey to that, because independent investigation of the truth, you know, don't believe everything I say, because it may or may not work in your situation. But you know, investigate the truth and find those answers for yourself. You know, I make products, but I don't have any illusion that I can get it to Uganda, right? The cost would be too much. But we can work with people in Uganda and find natural resources and tools that might help them, you know. And the other thing I should say is I am not a nonprofit. I am a commercial enterprise, so I do, but we operate from the sense of, you know, we make money selling our services and products, and then our educational programs and our outreach programs are to share our knowledge. So we're fairly open source. We try to be transparent about how we operate, and, you know, when we can, we share, and when we can, we sell. So, and share at the same time. So.
And so around the carbon, there was a question around carbon. And so for people who are asking, one, how you get more carbon in the soil, that was one question. And then, you know, you showed a tree crop that can be grown that's very high in nitrogen, right? And so carbon and nitrogen are two key things we want to manage for making compost. Yep. Could you speak a little bit more about how you teach people to, you know, charge the soil with carbon? And, you know, I'm assuming that the tree crop was being grown for the nitrogen rich leaves, but I wasn't sure if maybe it was the carbon that you were drying them out or something. So if you could share a little bit more about those things, I think people would be interested to hear.
Some of the research, well, I'll get into that. I'll keep it simple. You need the carbon from the trees. You need the carbon from plants, you know, the lignins and the high carbon content. And you need to, the thing about carbon is that it will oxidize and blow off really quickly if you disturb the soil. So that's why no-till is a good idea, to prevent the loss of the carbon. Building the organic matter, creating a good compost that's high in carbon inputs. You know, the general conditions of a soil, you know, it varies a lot and depends on who you ask, but anywhere from 15 to 30 to 1 carbon to nitrogen. And, you know, from what I've seen, the sweet spot is 25 to 1. Okay, that's fine, whatever. But when you look at things like bacteria has a carbon to nitrogen ratio of 5 or 6 to 1, whereas fungi can have anywhere from 20 to 100 or even 1,000 to 1. So fungi is actually a really important component of the carbon content in the soil, because it has a high C to N ratio. It's chitinous components in the shell and the way it works and functions. And also it's great at sequestering the fungi and actually making it. So biology makes carbon in the soil. Organic matter additions do not make carbon in the soil. They're just food resources for the microbes. So there's some research that's been done that says even with as little as 0.5% of organic matter, if the biology is functioning well, you can still have adequate levels of carbon and hold the soil together. So, and it's a big deal right now. There's a lot of people focused on carbon sequestration, carbon cycle, offset of our carbon footprint, all of that. And so one of the things that this test that we're talking about that we shared with you, is that when we calculate your fungi and bacteria component in the soil, we also can factor the living carbon and the living nitrogen of that soil from the biology itself. Just from knowing the bacteria and fungal population, we can also determine your carbon and nitrogen in a living sense. So there's all these different pools. There's total carbon, there's active carbon, there's stable carbon, there's all these different things. And you can go online and read all of the arguments about carbon and carbon testing. I'm not terribly interested in most of those things, because I just think it's just a fun academic exercise most of the time. But this living component of the carbon, if you can start monitoring that, you know, I did this test for my in-laws in their front yard and their backyard, both grasses, both pretty much the same, but the front yard has some issues. But the living carbon of that front yard was about 900 pounds per acre. But their backyard, which was functioning well and didn't have the same issues, was 2.5 or 2,500 pounds of carbon per acre in that soil. And they were very sandy soils. And it still had over a ton per acre of living carbon in that yard, you know. And of course, you can calculate how much they actually had, but that we do it on a per acre, pounds per acre basis. So just in those two areas, so you can, you know, and the carbon content is going to be more important for industrial nations, but it's also important for supporting life in the soil, you know. And so these are just another perspective, but it's a very accessible perspective, and it's a very consistent perspective too. I'm really, that's the one part that I really like, you know. I mean, as full disclosure, my standard deviation on our direct microscopy is plus or minus 20%. So if we made a 10 or 15% change in the system, we don't even see it. Whereas the microbiometer is less than 5% standard deviation. So we see, and only because it's dependent on process and not technique, right? Ours is my eyes, my eyes make the determination of what is being seen. And so that becomes a real challenge for training and for consistency, because what I see in the morning versus what I see in the afternoon may be a little different because I'm tired, or, you know, who knows, right? So there's a lot of standard deviation with that. Still a useful tool, obviously, and doing it for a long time, but, you know, it's, so anyways.
Well, that addresses one question, because one question had asked, can your test tell how much carbon is in the soil?
Oh,
And so it sounds like you answered that.
it tells you one view on carbon in the soil. Doesn't tell you everything that there is to know about carbon in the soil, but it's, again, you know, to get an actual true carbon reading on a soil, you need to have you need to do the loss on ignition test, which means you need to have a gas furnace that you can burn it and measure, and a spectrometer to measure the actual carbon to get a total. I got my ion machine that does that, but it's $100,000 for that machine just to measure carbon, and I'm like, that's not probably going to be worth it.
Right. And often you can send that off to Cornell or whatever if you're, you know, in the United States and get stuff.
Plenty of labs that would be happy to do the carbon test for us. In fact, there's 3 within driving distance of me. So
Great. So there's a question that's been in the chat, and then we'll come back. I think maybe Janet and Ned have their hand up again. So we'll come back to you in a minute. But there was a question around, has there been any work on seaweed as a soil supplement? And Mark, so that Arthur Dahl asked that. And then Mark Griffin asked, said, small island developing nations growing food is a current topic at the United Nations, especially with the food summit this week. So of course, seaweed, you know, is something that coastal areas have more access to. So we'd love to hear more about that.
So the answer is, oh, yes. Yes, very much so. My product has North Atlantic sea kelp in it, the Nidosum cephalum, I think that's how you say it. Anyways, North Atlantic kelp, there's work, Oregon State University has got, they're studying, there's like 30 or 40, at least 30 or 40 species of kelps growing off the coast of Oregon, Washington, up into the San Juans. I worked when I was in Ukraine. We harvested off the Black Sea. They have these huge mats of the seaweed and kelp come in, and we were harvesting those, and they were really, really useful. Seaweed is a great tool. The other thing that we're working with is actual sea minerals. So we're, you know, when they dehydrate the seawater, those sea minerals in tiny doses can be incredibly helpful, especially in nutrient deficient soils where they just don't have those trace minerals, the micronutrients. And so even though it's a salt, the salt index is actually quite low in all those minerals. And The other thing that we use is humic acid, which is also a very, very potentially locally sourceable material. And we have techniques for making it, as well as for, you know, how to utilize it in different things. So yeah, we use all kinds of stuff. And also fish waste is a big deal. You know, fish hydrolysate, enzymatically processed fish waste is an incredible resource that local. That was, so was supposed to go back to Haiti for a third trip, and our third trip was to visit the local fish market and start collecting and having the farmers learn how to collect the waste and turn that into a good fertilizer component for their projects and stuff. And believe me, there's a lot of waste, almost, and even in the poorest country in the world, what they still think it might be just a waste or junk, and it's actually an incredible asset. And so that's one of my personal goals, is to help people learn how to do those things so that they can see it where they're at, right? You know, so yeah, so thanks for the question. Yeah, seaweed, humic acid, fish. We use soy meal, you know, plant-based protein as well. Soy and alfalfa meals are really great alternatives to some of the more conventional, you know, because I'm always looking for, you know, you need some nutrient for supporting the biology. And that's the way we approach fertility, is we feed the soil, we don't feed the plants. So if you're growing corn in the Midwest and you need 250 units of nitrogen per acre of chemical fertilizer, then the reality is that that's probably 80 to 90% overkill, because they know it's not getting to the plant. So now you can reduce that to 10%, and that means you need 25 pounds, which is about 2.5 gallons of fish. And the fish feeds the biology, not the plant, and then the biology will feed the plants. So it's the same with the kelp, tiny amounts. You don't need a lot, because you're trying to feed the microbes and get them doing their job. You know, so I tell people this all the time, and you know, walk out into the forest and tell me who's fertilizing those crops, who's fertilizing those trees, and all of that biomass production. You know, there's a system. You know, we have to learn what that system is. The last 100 years, 150 years, we figured out how to divert that system and to subjugate it to industrial practices. So, you know, we don't, you know, for 15,000 years before that, we didn't have to do it that way, and we still fed quite a few people. And I think that we're completely capable of feeding the world without having to use industrial agricultural practices. So anyways, yes, lots of good stuff.
Okay, great. And one question around the seaweed, is the salt content and salination of soils at all an issue with that?
No. You rinse it off. I mean, the seaweed itself is not salty. And in fact, nothing coming out of the ocean typically is salty. In fact, seawater is not so salty. It's a very low salt index material. We can't drink it because there's chemicals in it that shut down our kidneys, and then we die. But it's not specifically the salt that's causing those problems. So salt water, seawater is pretty low salt index. I don't recommend irrigating with pure seawater, but there are ways to, we've worked on using compost as a biofilter. Can be a really great way to like process seawater through compost and let the biology and the organic matter grab on some of those nutrients, and then what comes out the other side would be much cleaner and probably be really useful for irrigation. So little things like that are, yeah, so.
Okay, and related to the whole fish and seaweed thing, there's a question, does fish emulsion degrade beyond helpfulness?
Yes, so there's different ways of dealing with the fish waste. So a fish emulsion, or commonly referred to as Alaska fish fertilizer for those in North America, that's an emulsion, and they take the fish and they boil it. And then they typically they'll boil everything down, and it breaks down all the proteins. It denatures it, and then they siphon off all the oil, which is the good part, and put it in pills and sell it to the health food industry. And then the rest of it, they add lavender oil to try and hide the stink, and then spray it out on your roses, and and then wonder why. And then they get to sell you the fungicide to control the black spot. So emulsions are not necessarily good. Hydrolysates are a better option, where the enzymes of the guts of the fish themselves break it down, or like in some areas we'll use mango or papaya juice with the enzymes to help break down the proteins. And so you want to try and keep because it's the amino acid and oil content that you want to preserve in the fish. And so boiling it just basically ruins all that. So emulsion is not necessarily the best choice, whereas a hydrolysate, it's also called a cold process of fish waste. And the bones and scales and everything too are also very useful. Most commercial products, they'll filter that off and throw it away, or they'll put it in a bag and sell it to the organic gardeners. And it's a great source of calcium and other nutrients as well. So use it all.
Right. Wonderful. Janet and Ned, did you have another question or comment?
Yes, I did. I was in a small farmer's field, and there's a lot of striga weed here, but this small farmer had planted lots of sesbania trees, which are nitrogen fixing, and he didn't have any striga weed in his maize, unlike most of the monocrop maize around him. And so I wondered, I said, well, wow, you don't have striga, is it? He said, yeah, since I planted this sesbania, the striga has gone down. So I wondered, is that a reasonable thing? Like, how could I test that? How could I prove it? So I could encourage more farmers to plant sesbania, because it's a nice growing tree.
So the concept is that the trees are going to, the roots of the trees will change the soil profile as well. So it's a two-way street. Okay, so that's part of the whole part of it as well, is that the plants influence the soil microbiology as much as the soil microbiology can influence the plants. And when you get the tree in there, building up the fungal content in the root system, reducing the pH of the soil, and making a more favorable habitat, probably helping hold water better as well, it could change that whole profile. And especially with annual weeds, that will crowd out annual weeds quickly. And then you're just creating, you've changed the ecosystem, even on a micro scale. And that's where this test kit that I'm talking about can be really helpful, because you can test the soils in different areas and say, oh, well, here I'm doing really well, and I've got a high fungal content, or over here, this plant is doing well. And it could be that, it's more appropriate to have a lower bacterial content. And so then you can start comparing and adding another piece of knowledge besides just the tree, but here's one perspective of what's going on, is then you can say, you can help other farmers manage to get those conditions similar to what that farmer is getting, and that's the way I approach, it's just the way I approach it. It's just like, here's, and that's phenomenology, right? You just observe, you look, you observe, and then you try and mimic what's going on and see if that happens again for this other farmer. And maybe another tree would work better than the one that the farmer you were working with had, or appropriate compost. Maybe compost is enough to get that same condition. So you can start playing with it, and it's fun to play with it, because when they start seeing changes and they're involved in the process of those changes, it's just, then they fully own it. That's the thing I love about the work we do in Haiti, is that is their project. I just gave them some knowledge, and then they ran off with it and just doing great things, right? So that's the hope, right?
I should just add, this sesbania tree is a nitrogen fixer.
Yeah. So just because they're a nitrogen fixer doesn't mean that they don't support a huge amount of fungi. Okay, all a nitrogen fixer means is that they can pull excess nitrogen out of the soil. And here's one of the things that we do know, especially about annual weeds. The reason that American farmers have such a hard time with weeds is because they over fertilize. So if there's too much nitrogen in the soil, not enough fungi, and not enough carbon than weeds do well. You take that away, and the trees contribute to that. A, they're pulling up the nitrogen, and B, they're also changing the pH profile and adding, and a lot of the plants put out exudates. So a lot of the carbon, when they collect it from the atmosphere, a lot of that carbon that they're collecting actually goes into the soil through the roots to feed and support the biochemical processes in the root system, which really means that they're helping feed the biology. And when you got a tree pulling in more carbon and putting that into the root system, it's collecting the nitrogen and putting carbon into the soil, and that's what fungi likes to live off of. So it's, like I said, we can go down the rabbit hole, and it takes 2 days to go through all of this stuff in my workshops. The book that I recommend, that'll take you a while to read through all that, the microbiology, ecology, and biochemistry. So,
Can I just ask another question too? Is one of the colleagues in our group at the Food System Game Changers is from India, and there's a tradition there that they take a cloth full of rice and they plant it in the roots of the oldest tree they can find, and then let it stay there for a week or two, and then pull it up and then scatter that amongst the crop to improve the crops.
Yep.
So does that kind of
they call that indigenous microorganism practices that did come out of India and South, and also parts of Asia. That what's happening there is you're putting a food resource at the base of the tree, and the organisms come in and colonize it and eat it and then you can use that as an inoculant into other areas to distribute some of those beneficial so basically distribute that oldest tree is going to presumably have the most diverse biology. So it's a way to share the wealth without sacrificing anything except some rice. So.
Right. Jay has his hand up, and I have a few more questions also in the chat box. So why don't we let Jay go ahead and ask his question and then go on.
All right, thank you. I grow ornamental plants and agricultural plants. And what you were saying about the trees, it made me think about growing a redbud tree, which fixes nitrogen. It's a legume, and then having winter plants growing underneath that when the trees drop their leaves.
Mm-hmm.
So do you have any advice or any ideas about if that's a good idea or not?
Well, the way I would look at it is, and that's part of permaculture, right? That's permaculture practices. You want to make sure that your companion plants, your understory plants, are compatible with that redbud. So my advice would be to find a redbud in nature and see what grows under it naturally, and then make sure that the plants that you're putting underneath it are in that kind of family, right? So, if you start having troubles with plants growing underneath the redbud, then there could be issues in that top layer of the soil that may not be compatible with the plants. So, we run into that all the time out here. Like the black walnut is an example that I like to use a lot.
Right. I know about the black walnut.
When you look at what grows under a black walnut, it's like, keep the ground bare, and that's probably as good as it's going to get.
Right.
Because
Yeah.
everything, it's got allelopathic components, and it actually poisons everything around it to prevent competition. Other plants are the exact opposite. They want everything and anything to grow in the understory under those plants. So, basically it comes down to grow things that are suitable for that plant's ecosystem, right? And it doesn't have to be an actual native. It can just be in the same family. So like, here we have oaks, and the rhododendrons do really well under the oaks here.
Okay, I'm thinking about growing agricultural plants like collard greens or cabbage underneath the redbud trees.
Now you've separated. You went into an annual system. almost to a weed level of succession with a highly bacterial types of plants. So it may not be the best option to grow underneath a tree, right? Broccoli growing under a tree is not something that you're ever going to really find in nature. But there may be other things that you can grow under the redbud, and there may be value to the redbud leaves as part of a compost that you could use to help grow the annuals. So again, it's find things that are compatible, so in succession, trees usually have woody perennials, smaller woody perennials growing underneath them. There may be some vegetative perennials, but very rarely do you find vegetative annuals growing under trees. So,
Right.
It's just, and that Edible Forest Garden book, it's a 2-volume book. You can still get that on Amazon. That's a great resource as well, because that's exactly that's agroforestry, right? You want trees, you want fruit and vegetables, and probably, animals at some point. And, that would be a good resource as well.
Probably not a good idea then to try to grow agriculture plants underneath horticultural trees.
I think it depends, right? It may or may.
I'll experiment.
If you look in the Edible Forest Gardens book, there's a whole index. One of the things that's wonderful about that book is there's a whole matrix of different plants and what they will grow well with and what not. So that's, it's worth its weight in gold just because of those resources. So we have a few more kind of practical questions, but as we transition, I'm going to ask those in a moment. But what I would like to invite folks, anyone here. So thank you, for coming to this agriculture working group of the Association for Baha'i Studies and presenting on soils. And I think, one of the things that you've really highlighted so wonderfully for us is soil is a very complex living organism, right? It's not a substrate, so to speak, right? And we need to interact with it as a living organism. And so, as we transition out of this, I'd like to invite anyone here to be thinking about what concepts or quotes from the Baha'i writings are relevant for you about the importance of soil for humanity and, in agriculture and for humanity's peaceful future. So I want to invite everyone to be thinking about that, and we'll use that to close out. But before we go there, there's a few technical things. So folks both from Kenya and Uganda asked about how they could get the test kit. So I think that access issue is a question.
So just reach out to us. I think we gave you our email either, and actually reach directly, Matt, M-A-T-T at earthfort.com or Kinzer at earthfort.com. And just reach out to us. We ship things all over the world all the time. So we have the ability to get things to people, and we can help facilitate that. Also, the folks at Microbiometer are also, one of their big premises and their hopes is that more and more people will use this on an international level, basically, especially Africa. So we can get it to you. We just need to figure out the logistics and, all the little details, and we're good at that.
Wonderful.
I shipped product to the EU and it went through. I was shocked. So, I think we can get stuff to Africa. And also the project that I'm working on with through the USAID in Uganda is going to bring me to Uganda. They want me to come to do the actual training. And so I would like to stay in touch with you guys, because it's all about collaboration, inclusiveness. If we come and you guys need a few kits or something, we'll make sure we bring a couple extra and stuff. And, hopefully we can connect. Uganda is kind of a big place, but you never know. You never know how close we'll end up being. I'd like to keep that I'm trying to, I'm trying to reach out to Rainn Wilson about his project in Haiti as well, and trying to connect our work with his work. Is very different, but I think that there's connection points that we could make. And so, yeah, anyway, so yeah, we'll just reach out to us. We'll figure it out. We'll find a way.
Fantastic. Another question there was here. Let me see. Don't want to make sure I didn't miss it. Oh, yes. Can you give us some idea of the commercial scale of Earthfort, its volume of products, its marketing network, and specifically, do you have any customers in Canada? And if so, which provinces? That's from Neil,
Yep.
who is in Ontario.
Yep. So we're, I have global reach for testing. We get testing from all over the world, mostly the EU, Canada, all over the US. We get some stuff from Central and South America. We do some work in Asia as well for the testing. We have a permit that allows us to accept the soils for that purpose through the USDA. The products, we're building a network. We got a distributor in Montana that we're working with and trying to get some retail. I was actually just looking at that. We've got product all over the US. We just got the product approved for the EU. So we'll be exploring that. It's too expensive. So we're probably going to end up doing a manufacturing agreement with the EU to build it, make the products there instead of trying to ship them. Some of our products are difficult because they actually have biology in them and on the label, so that's not appropriate for Canada. They won't allow it. But the other product that we have that's actually more important is the food resource that helps feed and stimulate the biology. That's not a problem at all. So as far as, scale is, we're a small company. I only have 8 employees. We do, well, before COVID hit, we were a $1 million company. Now we're about $700,000 or so. So we're small. We're a small company. The products are not, they seem, they're not overly priced. A farmer can be using our products in America and be spending anywhere from $10 to $30 an acre at the most, depending on what their conditions are. So, if you're interested in having some product in Canada, there's 2 ways to go about it. One is through an official distributor, or we can just send it direct to a farmer. So if you just want to use the product, we can send it direct. Otherwise, there could be some paperwork involved. That's usually what it is. It's just paperwork. So.
Great. And Kinzer has dropped both Matt and Kinzer's emails into the email chat box because that's probably the best way is if you reach out to them. I don't know if they're going to get a chance to grab emails out of this. So wonderful. Let's see, what do folks come up with? How does this wonderful presentation that really portrays the vital nature of the living soils for feeding humanity, all right, and also caring for our beloved life sheds that support us, how does that tie into your understanding around what the Baha'i teachings are? Let's bring a few of those threads in. Winnie, I know you think about this all the time.
Well, I'm thinking about how much that Abdu'l-Baha talks about cooperation and reciprocity, etc. And that seems to me the whole theme of this presentation from Matt.
Thank you. Anyone else have anything you're thinking of? I'm thinking, I will paraphrase, but I'm thinking of the quote that says, any man of discernment when walking upon the soil will realize that the source of all wealth is from beneath their feet, and that awe of understanding that all wealth really comes from the soil is in turn very humbling for us as humans. So I wish I had it memorized, but I love that quote so much.
Yeah, the thing that I think of is, and Matt, you mentioned this about independent investigation of truth. And I think this is one of the fascinating things about working in agriculture, is that every day is like that. You're what's going on here? What's going on here? Why is this plant reacting this way? Why does this not grow in this spot? And that's one of the interesting things about it. And I think that applies, that independent investigation of truth is something that makes life interesting.
Mm-hmm. I thought of that when you said phenomenology too. Yeah. Sorry, was that Joe? Who was going to say something?
Yeah, I was thinking about every man of discernment also, but there's another in talking about spiritual springtime. Abdu'l-Baha talks about leaping and dancing in the procession of the covenant. And so that sort of fits in with the notion of succession. And I mean, all this is a dance. The interactions of materials in the soil is a dance, and we're walking on it, we're dancing with it, and the plants are dancing out of the earth towards the sun. I mean, so we're all leaping and dancing in the procession of the covenant as we have this succession going from, families to tribes to cities to nations to planets. And that's what I was thinking.
Mm. Thank you. And Neil, had you unmuted yourself too, Neil? I wasn't sure. Okay, go ahead, Janet.
I was just following on what he was saying about the dance, because I was out in the field with mamas recently and bringing them trees that they wanted. And once I'd given all the trees, they started having a dance. So I look absolutely idiotic, dancing with them, but that's what they wanted to do. They were so happy to get these trees to improve their farming. And so then we just spontaneously started dancing. I don't know if it's a traditional dance in Uganda, but it was wonderful. It's about 40 mamas dancing with their trees.
Neil in Canada. Neil Watley, did you want to say?
Yeah, can you hear me okay?
Yeah, we can.
Okay, it's a great talk, Matthew. Thank you very much. And I really appreciate your humble attitude towards the earth and to soil, and especially the practical application of what you're doing. It's a real service to humanity, and it focuses on the farmer, who's the first active agent of human society, according to Abdu'l-Baha. So congratulations, keep up the good work, and hello to everybody online here.
Mm-hmm. Yeah, it's always wonderful to see everyone. Janet shared that quote that I was paraphrasing badly. So I think what I'd love to do is I'll read that quote, and then we'll let Dawn do any, kind of closing announcements. But before I read the quote, I want to just thank you, Matthew and Kinzer, so much for being with us today. Such an informative presentation, and I think it's all deepened our love for the living soil and how we can work with it. So thank you. So I'll read this quote. This is from Baha'u'llah. It says, "Every man of discernment, while walking upon the earth, feeleth indeed abashed, inasmuch as he is fully aware that the thing which is the source of his prosperity, his wealth, his might, his exaltation, his advancement and power, is, as ordained by God, the very earth which is trodden beneath the feet of all men." Great. Thanks again, folks. And I'll hand it over to Dawn. Close this out.
Yes, thank you everyone for being here. Just want to mention that next month, our presentation will be Bill Hazen is going to present and talk about his experience in the transition from conventional farming to organic farming, which is, that's something that many of us have wondered about. How do you switch, and what are the issues, and why do people want to do that? And so anyway, we're going to hear from Bill Hazen next month. That will be the last Sunday of the month. It will be October 31st, I believe. So we'll look forward to seeing you all there.
Big shoes to fill after all these speakers.
We can't wait to have you, Bill.
I just want to add in that Bill has been taking pictures of his process from the beginning to the end. So I think it's going to be wonderful to see exactly what he does as an organic farmer of 200 acres.
It's going to be really localized because it's focused here in Ontario, right? So some of the things I do, you can't do in Africa, and just like Matthew was saying, it's specific for our area. So
Still learn though. You can still learn.
And
Yeah,
I
the
think one of
principles
the
often.
interesting ideas, Bill, will be, what do you see as your future with the way that is the climate changing there like it is here? We've had the hottest summer. So I'll be interested in, do you think you'll be able to continue farming the way you are? I'll just leave that for now.
okay, stay tuned.
Okay, and some folks are saying they came late, and the presentation recording will be shared. And if you're not on the mailing list to hear about future presentations, just stay here for a minute and we'll drop the chat, that in the chat for you. But I think probably pretty much everybody else already is. So, all right, thanks again to our wonderful presenters. Thanks to Dawn for all your work behind the scenes organizing, and the organizing team, convening team, I guess, for the work to put these wonderful presentations together. Thanks, everyone.
Thank you. Take care.